This is a video on solving polynomial equations of higher order by expressing them in terms of polynomial equations of smaller or lesser order. Okay. So it's a simple one. Here I will just take one simple example. I try to express a bi-quadratic equation of degree 4 as the product of two quadratic terms, quadratic expressions, and try to simply solve them. It's very easy. You can do it. You can. Thus, we can write a bi-quadratic equation in the form ax power 4 plus bx cube plus cx square plus d times x plus e. I will express this as a1x square plus b1x plus c1 times a0 x square plus b0 x plus c0. Okay. So if we expand the terms, we will get it as a0 a1 x1 power 4 plus a1 b0 x cube plus a1 c0 x square plus a0 b1 x cube plus b0 b1 x square plus c0 b1 x plus a0 c1 x square plus b0 c1 x plus c0 c1. So this is the left hand side and this one is the right hand side, which has been expanded. If we collect and group all the like terms together, we will get this equation. This will be equal to a0 a1 x power 4 a1 b0 plus a0 a1 b0 plus a0 b1 times x cube plus a1 c0 plus a0 c1 plus b0 b1 x square plus c0 b1 plus b0 c1 times x plus c0 c1 is equal to 0. Comparing the corresponding coefficients a, b, c, d with these for x power 4 and all corresponding powers, we will get the following. get the following. We will get A naught A1 is equal to A1 B naught plus A naught B1 is equal to B A1 C naught plus A naught C1 plus B naught B1 is equal to C C naught B1 plus B naught C1 is equal to D, and C naught C1 is equal to E. So as you can see, this is the coefficient. Now what we can do is we can simply assume, say, for A naught and C naught, and try to determine B naught and B1. Okay. So these C naught, A naught and C naught can be assumed some value. Correspondingly, A1 will be A by A1, C1 will be E by C1. Assuming A naught A1 and the other value A1 for A naught C naught, determining A1 and C1, we can try to determine using these two equations. We can try to solve for B naught and B1. Having done that, we plug for the assumed values of A naught and C naught. We have obtained A1 C1, B naught B1. We plug those values into this and see if the identity holds good. If it does, it means that we have accurately determined all the coefficients. So we can express a polynomial expression of a higher degree as a product of polynomial expression of two smaller degrees. Thus, we can solve the two polynomial equations of smaller degree by solving the two of the we can solve the polynomial equation of larger degree by solving the polynomial equation of two smaller degrees. Or if you can try and, if you want to have more number of variables, you can use 3 or 4 also. That might be a little bit more elaborated. So now we try and solve that one. We have A1 is equal to A by A naught and C1 is equal to C by C naught. We assume A naught, A1 and A naught and C naught, some values. Then we have A by A naught times B naught plus A naught B1 is equal to B, and in other words, we also have A1 C naught plus we also have C naught B1 plus E by C naught B naught is equal to D, right? this comes out, these two equations come out as follows: c naught square b1 plus e times b naught is equal to c naught d. A naught square b1 plus a times b naught is equal to a naught into b. Okay. So these are the two equations. We have to solve for b1 and b naught. The system of two linear equations, similar to equations. All these were constants assumed. So we can simply solve that. Let me multiply this. So I'll just give you the final formula here. You can easily solve it. We get b naught is equal to a naught square c naught d minus c naught square a naught b by a naught square e minus c naught square a. And we have b1 likewise equal to a naught e b minus c naught a d by a naught square e minus c naught square a. Okay, so we have determined b naught and b1. So we now have to check whether from the third one, from the other remaining equations, we have to plug in all the values to check if right, that is a by a naught c1 a by a naught c naught plus a naught e by c naught plus b naught b1 is equal to c. If it satisfies, that means we can express that polynomial as the product of these two polynomials. And so that bi-quadratic equation can be expressed as a product of two quadratic equations, and those two quadratic equations can be solved. In general, we can try to express it as the product of more than two also possibly, but two is sufficient, more than sufficient. A binary break should help us. So this means we can solve higher order polynomial equations always in terms of smaller and lesser order polynomial equations. I mean lesser degree polynomial equations.